Hello, everyone. Welcome to the Hydra Developer Bootcamp for Week 2, Day 4. I'm Bo from ChatDE, and I'll be the moderator today. Today, we're going to have lectures related to Solidity grammar and creating smart contract using Solidity. We hope you guys could not just get a glimpse of what smart contract creates, but we want you to know how it works from step to step. Our instructor today is Mr. Ali. He is the overseas community manager from ChatDE and he's also the technical ambassador of ChatDE for years. Ali, you may start whenever you're ready.
This is Ali from Chain IDE, and today I will be talking about Web3 development. So I would like to share my presentation. Thank you. So I will be talking about Web3 development today. How you can create your smart contract and can deploy on different blockchains. So this bootcamp is supported by Conflux blockchain. So we will be using Conflux blockchain. And for all the applicants who have participated in Hydra Developer Bootcamp, they also need to deploy their smart contract on Conflux blockchain. So here is today's agenda. First of all, I will discuss about life cycle of a software, and then we will discuss a little about why we need blockchain, like what are the things that cannot be done using traditional databases such as SQL, MySQL, and other databases, why we need blockchain. The third one is Solidity grammar. We will discuss all the features and functionalities of Solidity, and in the end, we will discuss about Web3.js library that is used to interact with the deployed smart contract from the front end. And we will discuss a little about HTML and CSS also. In the end, we will design a small application having front end in HTML and CSS, and in the back end we will use Solidity to create a smart contract and deploy on the blockchain. So I will start with the life cycle of a software. So we cannot start directly like implementation or coding. First of all, we need to plan like what we want to develop. We need to mention all the requirements. We need to do requirement elicitation for our software. After planning, the second step is analysis. We need to analyze all the requirements of a software, and then we go to design. The design is also known as a prototype. There are different tools we can use to create a design of a software. uh, yeah, such as maybe you can use Canva or some other tools, prototyping tools, to make a prototype for a software before you move to implementation. The implementation includes coding, the front end and back end development. The front end, there are different programming languages for front end and back end, such as HTML, CSS, JavaScript, React, Vue are used for front end, uh, for creating front end. And for back ends, if we talk about blockchain, Solidity is the most commonly used one. Except Solidity, Python, C Sharp, Rust, and many other programming languages are also used. For example, for Flow blockchain, Cadence programming language is used. Like there are different programming languages based on the blockchain you are going to write down smart contract for. And the last step is testing and deployment. uh, Once you have created all the software, the last step is testing and development and deployment. After deployment, you go for maintenance. You do some add some features, remove some bugs in each iteration. That is called maintenance. So So these are the stages of software development. like any application development, we don't go to coding directly. We need to plan first, then we analyze the requirements, all the functionals and non-functional requirements, then we create a design implementation. So in the requirement phase, we create a document that is known as that is known as software requirement specification. And in that document, we create different diagrams also, such as entity relationship diagram, flow diagram, use case diagram, and many other diagrams to understand the whole use case of your project. And we define all the requirements, all the functional requirements and non-functional requirements. Non-functional requirements are like availability, like it should be available to all the users for 24 hours a day. And usability, it should be easy to use for all the audience, like there shouldn't be any thing that is hard or like hard to use for the audience. And the third one is design the product architecture. Like we make design of the software using some tools. We can create a prototype. For example, if you are developing a software for someone else, not for yourself, so we mention all the requirements first. So later we test according to the requirements. And the fourth stage is building or developing the project. This is the most important stage, and we will be uh, discussing this stage during this lecture, like how we can develop or build a blockchain based application, what are the tools required, what are the programming languages like for front end and for back end. As I already discussed earlier, like for front end we will use HTML, CSS, and JavaScript. HTML is commonly used for creating the content of the website. CSS is used for styling, like adding colors and to make it more stylish. There are other frameworks also like React, Vue, and we will look about those frameworks also in later videos. But in this video, we will just touch HTML, CSS, JavaScript, and Solidity. So once we have created our project, the next step is testing. Like before deploying or before handing it to the customer, we it. There are different like testing cases also, like unit testing, integration testing, load testing, like how many users can access your website at the same time, like that is known as load testing. There are different methods to test your product before you deploy it. And after testing, you hand it to your customer or you deploy it. And after deployment, once your like customer or you have some extra features or there are any bugs, so you will work on resolving that bugs, or you will add some extra features, that is known as maintenance. So these were the stages of software development or any application development. We talk about any Web3 application or D app. And in these stages, we will do some comparison also, like competitor analysis, like we do SWOT analysis, so strength, weaknesses, and opportunities and threat. Like we compare our project with our like competitor, and we check what our weakness is, how we can create improve our project, and what are our strengths, yeah, and what are the threats to our projects. So during these stages we do SWOT analysis also, and it can help to have a better project at the end. So we will mainly discuss about building or developing the product. So there are two main programming languages. Like one is front end, the second one is back end. The middle is also like the integration to integrate the front end with the back end. For example, if we talk about in our case, if we talk about blockchain based application, we create a front end in HTML and CSS or React, and we create our backend in Solidity programming language. But to integrate the front end with the backend, we use JavaScript. So that is also known as, like, JavaScript is also known as front end programming language, but backend, the smart contract is deployed on the blockchain, and we use API and JSON code of the smart contract to interact with the backend using the HTML and CSS. We will like see this all in the demo at the end of this lecture. So as I already discussed, front end is HTML, JavaScript, CSS, React framework we can use as a front end, and there are many others also. There are many others also. That is your own choice, like which one you feel comfortable with. But if you are good at one programming language, it is very easy for you to like be good at another programming language. For example, if you are good at C++, it is very easy for you to learn Python also, or to learn Solidity. All the things are very similar in like different programming languages, like the data types, functions, polymorphism, inheritance, and like function overloading, function overriding. All the concepts are similar. Just the like the there is a difference in like typing. Context is different, like the all the concepts are same. So we will talk about Solidity now. Solidity is object oriented programming language. Object oriented programming languages are like the programming languages that you see use uh, contracts or classes, you can say. The programming languages in which we have like functions, and we have classes or we have contracts, and we can create the objects of those classes, and we can use inheritance. These programming languages are known as object oriented programming languages. And there are two types of programming languages: high level languages and low level languages. High level languages are used for, easy for the human understanding, but the low level programming languages are used to interact with the machine. For example, the high level programming languages are converted into low level programming languages using some compiler. So low level programming languages are understandable by the hardware, like those are in 0 1 form. But high level programming languages are easy to understand by the humans. For example, Solidity, Python, all these are high level programming languages. So, and Solidity is a statically typed, and there are two type of like languages: statically and dynamically typed languages. A statically typed language, we need to define it first, define the variable first before we can use it. For example, if we want to use an integer, we need to define it first, declare it first, and then we need to define it. But dynamically typed programming languages can be directly defined. We don't need to declare them first. Don't need to declare their data types first. For example, in Solidity, we need to declare first int for the data type. For if we want to use some variable of type integer, we need to declare a data type int first. And if we want to use a string, we need to declare a variable with data type string before using it. But if we talk about Python, that is not the case with Python. Python is a dynamically typed language. So we don't need to declare a data type first, we can define directly. And it supports inheritance like other programming languages such as C++, C Sharp. Like we can inherit the features from a parent class or from a parent contract to a derived contract or a derived class. And it supports libraries also and user defined data types also. So we will talk about EVM. So blockchains are EVM supported. All the code is like executed by the EVM. The Ethereum virtual machine, also known as EVM, is a runtime environment for smart contract. Like your smart contract is deployed in the Ethereum or like executed in the Ethereum virtual machine, and it provides security and executing understandable code by computers all over the world. What does it mean? Computers all over the world. In a blockchain, there are different nodes, and those nodes you can say computers all over the world. If we talk about any blockchain, for example, if we talk about Binance Smart Chain, it has 21 nodes all around the world. So all the nodes have the same data at on like every computer. So we can say like all those nodes have EVM, and your your smart contract is stored on all the nodes in the world. And same is the case with Ethereum blockchain and Bitcoin. And the EVM specialized in pretending denial of service attacks and ensures that programmers do not have access to each other's state. And it has been designed for blockchains such as Ethereum and all other EVM supported blockchains. So, what is a smart contract? A smart contract is like a class. If we talk about a C++ programming language or C sharp programming language or any like Python, a smart contract is like a class, and it has some data types and functions. And after like compiling, it creates a JSON and API code. And a smart contract is deployed on the blockchain after compilation. And once it is deployed, no one can make any change in the smart contract because it is deployed on all the nodes in the world. Sorry. And it is like deployed on all the nodes in the world. As I described earlier, if we talk about Binance Smart Chain, it has 21 nodes. And once we deploy our smart contract, it will be deployed on all the 21 nodes in the blockchain. So after deploying, we access one node like from the whole blockchain, and we can access the whole data from any node of the blockchain. So environment setup. If we talk about environment setup, for example, if you want to create a Web3 application or a D app, what things you need to have, like how you can code Solidity programming language or D app. So you can use Chain IDE, which is the like the world most commonly used IDE, and is being used in more than 185 countries, and it supports multiple uh, blockchains, including Conflux blockchain, Ethereum blockchain, Binance Smart Chain, and Definity blockchain, and many other consortium blockchains also. And it supports different programming languages, and it supports Flow blockchain also. So if we make comparisons with with other tools available such as Remix or Visual Studio Code, I think Chain IDE is the most suitable one because sorry, because you don't need to install any node package manager like separately in your computer system. You can access each and everything in Chain IDE. You don't need to install any extra software to write down a code. Like in Remix, if you talk about Remix, you need to install node package manager differently separately in your system, but that is not the case with Chain IDE. Chain IDE have all the plugins and all the Like you can use code manager also in the chain IDE. And the second thing is MetaMask. For when you deploy your smart contract on the blockchain, it is not deployed on your like server. You are using someone's resources, so you need to pay the gas fee for using that resources. So to pay the gas fee and making transactions to the blockchain, we need MetaMask. So you can install MetaMask from the Play Store if you are using Windows, and if you are using Mac operating system, you can use on your download on your Mac operating system also, following the requirements. So these are the environment setups. Once you have like access the chain IDE and you have downloaded the MetaMask, you can start development now. And the next thing is you need to know the Solidity for writing down the smart contract. Here is the basic syntax of a smart contract. First of all, you need to declare the version of the Solidity programming, a language or a compiler you want to use to compile your Solidity source code. So here pragma is used to define the compiler version. So here the compiler version will be between from 0.4.0 to 0.6.0. Like in between you can choose any compiler. So the next keyword is contract. A contract is as I already described, a contract is like a class. So it has some data and functions inside it. A contract is defined by a keyword contract, and and next to it is the contract name. The contract name is simple storage. So here are the next is value types. Like in other programming languages, Solidity also supports different value types, such as integer, unsigned integers, uh, address, and string, and many other like value types also. Unsigned integer is used to store both like the negative, or sorry, just the positive, not the negative values. But integers is used to store both negative and positive values. So the next is the function. Function is always used for the reusability. For example, if you want to call something again and again, if you want to use something again and again, you use a function and you call it whenever you need. A function have some parameters for the input and it gives some output. For example, if we say here unsigned int is used as an input, and here view returns is used as an input. A function takes some inputs and gives some output and is used for the like reusability. Here is the definition of a function again in Solidity. A function is a group of reusable codes that can be called anywhere in your program. This eliminates the need of writing the same code again and again. Yeah, for example, here you can change the values for unsigned int, but you can use the same function for different values. You don't need to like write down the different code for different values. You can use the same code and you can change the values. So this is the reusability. The comment, like other programming languages, Solidity also supports comment, and here we can use like single line comment and multiple line comment. This is the single line comment uh, tag, and this is the multiple line comment. A comment is used like for example to understand the code better. For example, I wrote down the code and someone else is reading it, but maybe he cannot understand the code very easily. So the a comment is used to explain the functionalities of a code so the other users can understand the code easily. And if he wants to make any changes in the code, he can like check the comments and understand the code first and can make changes easily. So without comments it might be hard for a coder to understand someone else's code, because everyone have different habits of coding. Yeah, value types. So there are different value types. For example, if you want to store integer type data, you will use int data type. If you want to store unsigned integer, for example, negative and positive values, so you will use unsigned integer data type. And if you want to use string, some text form, text data in the text format, so you will use string. And if you want to use your address or your ethereum address, so you will use address data type. And if you want to use like boolean, something in true and false, you will use boolean data types. And there are fixed and unfixed data types also. Variables. So if we talk about variables, there are three types of variables in Solidity: uh, state variable, local variables, and global variables. If we define a variable after the declaration of a contract but not in a function, so that is known as state variable. And the other one is local variable. The local variable are defined inside the function. So state variables can be used in the whole contract, can be used inside the function and outside the function or in the whole contract. So the local variables can just be used inside the function. So these are the local to the function in which these are declared. So we have global variables also. Global variables tells the information about the blockchain. For example, if we want to know the difficulty of the blockchain, so we will use block.difficulty. So this is the global variable which is used to know the information about the blockchain. Block.gas limit is also a global variable, like which is used to know the limit gas limit for the block number, like which block is at the present time, to know for a blockchain, is also a global variable. So as I talked earlier, there are three types of variables: state variable, and local variables, and global variables. So there are a different scope for a variable also, like public, internal, and private. Public state variable, yeah, here is one thing to note, like just state variable have a scope, not other variables like local and global variables don't have a scope, just state variable have a scope. So there are three scopes for a variable: public, internal, and private. A public variable, like when a state variable is declared as a public, it can be accessed internally, like inside a smart contract and outside the smart contract, like in a derived smart contract also. But if we talk about internal state variable, it can be accessed only inside a smart contract but not outside the smart contract. And the third one is private state variable. Those can be only accessed inside the smart contract but not the derived contract. So here is an example of a scope of a variable. Here we have public and internal variables. Here we have value type is unsigned integer. So public can be used both inside a smart contract and in the derived smart contract. If we talk about here, here is the internal access. So it is the like inside the smart contract. And if we talk about here, idata 10 is also an like inside the smart contract. And here is the external smart contract. Now, external access is not inside the smart contract but is in the derived smart contract. Here we have another contract and we derived it from the contract C. Here we see contract C is a parent contract you can say, and here we is a child contract, and we derived or used like data here, this data in a derived clause. So this is the external access. So just public can be used for the derived class but not the internal. Inter- Internal cannot be used outside the parent smart contract, can be used just within a parent smart contract. So Solidity have array also like other programming languages. When we want to store some specific data types to a uh, like data points, so we use array is like a data structure is which stores a fixed size sequential collection of elements of same data types. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of same data types. For example, here we defined an array of unsigned integers with three like value types. We can store three value types like at 0 index, 1 index, and 2 index. Here we stored unsigned int at 0 index, and here we stored 2 at 1 index, and here we stored 3 at 3 index. So there are two types of arrays, static arrays and dynamic arrays. In static arrays, we define the length of an array in advance. But in dynamic array, we don't define the length of an array in advance. So this is the difference between static array and dynamic arrays. Solidity supports structures also like C++ or C# programming language. A structure is used to represent a record. For example, if we want to store the record of a book, we will use some features of a book like book name, book title, book author name. So we can use structure to record the like data of a book or something else, a car, like features of a car, car owner name, car ID, car registration number. So we can use structure in these scenarios. So subtract is also defined as with keyword subtract, and inside the subtract we can define different data types, and here we create an instance or object of a structure. So later we will use this instance to store the data in the structure. So here we store the data. Learn Java is stored as a book name, and TP is like learn Java is used stored as a string title. TP is stored as a string author, and book ID is stored as one. So these are used to represent a record. So here we have a record one for book. For example, we have a record for book one. So the book name title is Learn Java, the author is TP, and the book ID is one. So here, if we want to get the information stored using the structure, so we will use like the structure instance and then the value type. For example, here we have structure instance book, and here we have data type book.id. So it will give us book ID that we use stored book like one. And if we use here book title, so it will return us learn Java. So this is the use of structured data types. A mapping is also very important in Solidity programming languages, and is used as an arrays or as structures. So here is like how you can use mapping. Mapping is also used as like keyword mapping, and here we have value types and key types. This is also known as value key combination, and here the balances, public balances. So here we have function, and here message dot sender, the one who is like using this, interacting with this smart contract using the like MetaMask. So there are different like types of function modifiers. Before we talked about functions, like there are different types of function: public functions, private functions. Like public functions can be used in derived class, and private functions can used be only in the like smart contract, not in the derived smart contract. So here we have two modifiers like view and pure. If we use a view with a function, it like then we cannot modify the state variables. Like we cannot emit events. Whenever we try to use the state variable with a function defined as view, it will like through an error. Like you cannot modify state variable because you are using a function as view. Here we have an example, so we are not using any state variable. But if we use any state variable, it will give us an error. Like you cannot use state variable if you use a view with a function. Here we can see how we define like function as a view. So we can only use local variables, but not the state variables or global variables inside it. Pure function ensure that they are not like they don't read or modify the state variable, or they don't like use some global variables like address this dot balance or address dot balance. Same is the case like we talked about view and pure, both are same but with a little difference. Like in view we cannot just read, but in pure we cannot read and modify the state variables. Yeah, here we have an example of a pure function. Here the function is defined as pure. So we cannot use the state variables, or we cannot use these commands in a function defined as pure. So function overriding. Solidity supports function overriding like other programming languages such as Java and C++. Like you can define functions with the same names, but it should have different parameters. For example, the function name is sum. The second name is also sum, but the first function is taking two parameters and the second function is taking three parameters. So this is known as function overloading. You can define a function, more than one function with the same name, but it should have different like parameters, arguments that are like that the function is taking. And you cannot overload functions declaration that differ only by return type. This is an example of function overloading. Here we have a contract, and here we have different functions. The function name is same. If we see like function 1 and function 2, the both names are same, but the arguments the function is taking are different. The first function is taking two arguments, and the second function is taking three arguments. So the same is the case with the function third and the function fourth. In function third, we are returning two arguments, but in function fourth, we are returning three arguments. So the number of arguments should be different. The name could be same. So this is the function overloading in Solidity. Inheritance, as I talked earlier, in Solidity, we can use inheritance like in C++ or C Sharp or Java. Inheritance is used to make use of the code we use in the parent class that can be used in the child class. So in inheritance, we do like define the most usable data types or functions in the parent class, and then we use if we need to use it again and again, and then we just can use or derive from the parent class. We don't need to declare or we don't need to like define all the things from start. We can just use from the parent class. So this is the use of inheritance. Constructor is also very important in Solidity. A constructor is declared with the keyword constructor, and when a smart contract is deployed, a smart like the is constructor is called like is called only once when the smart contract is deployed. So we use a constructor to define some values. So now we will have some demos. We will create a project using HTML, CSS, JavaScript, and we will use Solidity as a backend programming language. And the we will create another smart contract, crc20 smart contract. Crc20 is a standard for conflux fungible tokens. As we know, there are two types of tokens. The one is fungible tokens and the other one is non-fungible tokens. Fungible tokens are used to represent some virtual currencies like if we talk about Ethereum, ETH, Solana, SOL, CFX. For Conflux blockchain, these all are you can say 20 standard token. If it is deployed on the Ethereum blockchain, it is known as ERC20 standard token. But if it is deployed on the Binance Smart Chain, then it has like other standard BEP20 token. And if it is deployed on the Conflux blockchain, then it is known as CRC20 standard token. So we will create a code. We will create a fungible token CRC20 smart contract using chain IDE and a demo in which we will be using some smart contract to store some values and retrieve some values from the blockchain using front end. So here is the link like how we can add Conflux eSpace network, which is like eSpace test network in the MetaMask. So maybe you can copy this link and you can add Conflux network in the uh, MetaMask, like when we like code and we will use Conflux blockchain. I would like I would like to notify all the applicants again. This bootcamp is supported by the Conflux blockchain, and all the applicants who participated in the Conflux Hydra Developer Bootcamp need to deploy their blockchain applications on the Conflux blockchain. So this is one of the requirements. So now I will share my screen and we will start coding using Chain IDE. Yeah, so I would like to have access to share my screen now. Just wait a minute until I have access to share my screen. Yeah, so we will be using Chain IDE. Chain IDE has built-in templates also. For example, if you are a beginner and you don't know or you don't have uh, yeah For example, if you are a beginner and you don't have much understanding, so you can go to chain IDE. Here we have chain IDE. Chain IDE is a web-based, you can say, compiler. You don't need to install anything to like create a DApp using chain IDE. You can deploy your whole project using just chain IDE, this web-based browser. You don't need to install any node package manager or anything else separately. You can install each and everything inside it. So here are the different blockchains that chain IDE supports. Here we can see BNB chain, like which is Binance Smart Chain. Recently, they changed their name to BNB. Here Ethereum, and here Conflux blockchain, Definity, Flow blockchain, Cocos, BX, Ultrain, Polygon, and some other like consortium blockchains also. So there are two requirements. The first one is compiler, which is chain IDE. The second one is MetaMask. You need to install MetaMask wallet to pay for the when you deploy on the your smart contract on the blockchain. So if you don't have MetaMask, you simply can go to your Play Store here, Web Store. You can simply search for the MetaMask. If you search here MetaMask, you can get access to MetaMask after installing this web-based wallet. Yeah, I have already installed it, so it is asking for me remove from Chrome. So you will have like add to Chrome. So you can add it. After adding, you can like you will have something like this, and you can add different networks into your MetaMask wallet. So by default, it will have some Ethereum-based test networks and main networks. But for Conflux blockchain, you will have to add manually, or when you access to chain IDE and you go to Conflux blockchain, it will automatically add Conflux test network into your MetaMask. For example, here we go. You can sign in with GitHub, or you can skip like by signing in with GitHub, just go directly to Conflux blockchain. So here are the built-in templates. If you are a beginner, you are not good at coding, you can use these built-in templates to learn programming like Solidity programming language. So here are all the built-in templates. Here we have storage smart contract, which stores some values on the blockchain and retrieves some values back from the blockchain. Hello world is also same, like used to store hello world or some text on the blockchain and then retrieve from the blockchain. Vending machine and ERC20 showcase is, as I already talked, like a fungible token smart contract. If you want to create a token, your own token, you don't, if you don't even don't have a programming background, you can simply use chain IDE and can use this built-in template and can create your smart contract, deploy on any blockchain. Here we have different blockchains: Ethereum, BNB chain, chain 33 is a consortium blockchain, Definity, Nervous blockchain, Polygon, Flow. But for this bootcamp, we will use Conflux blockchain. So here you can use two methods to add Conflux test network to your MetaMask wallet. The one is like here, when you go to your, when you like open your application and you click here injected Web3 and MetaMask here, Conflux. If you don't have added, if the test network is already not in your MetaMask, you can click here switch and you can change here conflux space and here switch. So it will automatically add conflux space into your MetaMask wallet. So you don't need to add manually uh, the test network into your MetaMask wallet. So here we can see we have conflux space in added in our MetaMask wallet. So here we have conflux space test network also. So if you want for test network, we will use conflux space test net. But if you want to deploy your smart contract on the main network, so we will use conflux space main network. Same is the case like other blockchains. Each blockchain have uh, like test network and main network. For testing purposes, we will use test network when everything is confirmed, like when you are sure everything is working properly, then you will deploy your smart contract on the main network. So here if you want to add conflux space test network into your MetaMask wallet, so you will use conflux space test network and click switch, so and switch to network. So conflux space test network will be added to your MetaMask wallet. Yeah, here we can see I have already added conflux space test network into my MetaMask. So the other scenario is if you want to add manually, like if you don't want to add this way and you want to add manually, you can add manually also. You can go to settings, you can go to advanced, and here, oh sorry, you can go to here all the networks and you can click here add network, and here you can search conflux space test network. So you will get the information about how you can add conflux space test network into your MetaMask. Conflux space test network MetaMask. So yeah, this I think this way. Sorry, not this. Here we have MetaMask here. If you want to add manually, you can use this information to add manually also. Like if you want to add eSpace mainnet, you can use this information. And if you want to use eSpace testnet, you can use this information. You can like network name, network, uh, RPC, remote procedural call, this link chain ID, conflux symbol, and blog explorer URL. You can add all this information here, such as network name, conflux space testnet, or you can paste it here, a network URL. You will paste it here. Yeah, I have already added. So if you will add for the first time, will be successfully added. Because I already have, so it will not be repetitive. It can be added only once, unique one. Here the symbol is CFX. The conflux currency symbol is CFX, which represents conflux coin. So here you can add. Because I already have added, so I cannot add successfully. If you want to add manually, you can add manually also. So this was all the setup, how you can add conflux network to MetaMask wallet. I talked all the scenarios, and here is our chain ID. I will talk about chain ID now. Is available at www.chainide.com. So it has built-in templates, supports multiple programming languages, has each and everything. Like you don't need to install npm separately. Here we have Logger, and we can access truffle and hard hat, ganache, each and everything. In the terminal, we can use console. Like if you are using console commands, you can access in the console command line, and output can be seen in the output section. So here we write down some simple smart contracts for the beginners, like how they can use Chain IDE and MetaMask to create the simple smart contract. Here I have already written down some simple smart contract to understand the basics of Solidity. Here is the constructor smart contract to understand like how a constructor works. Here is the contract name. Here is the pragma, which is used to define the compiler version for the Solidity. We have different compiler version for the Solidity. Here we can see here are all the compiler version. The most updated one is 0.8.13, and these are all the compiler versions. So you can check the compatibility of your source code with your compiler version. So here we have value type and int and data. So here we used constructor to define the data. Sorry. Here we declare it, and here we define it. So this is the single line comment. This tag is used to define a single line comment. Here is the unsigned int data, and here we used constructor to define the value. There are like two things. One is declaration and one is definition. Here is declaration and here is definition. Here is we talked about like the Solidity is a statically typed language. We need to define the data type first. For example, we cannot just use it without defining the data type. Just like in Python, we can use it without defining the data type first, but in Solidity, we cannot use it. Here we need to define the data type first. So this um, chain ID supports IntelliSense also. For example, if you like write down some code, it will give you some suggestions on signing to make your coding experience better. So the chain ID supports IntelliSense also. Like it helps you to complete your code automatically and like in a better way. Here we used constructor to define the data type. Constructor is called only once when we deploy our smart contract. Here we have write down the smart contract, like the complete smart contract that is not taking some values but returning some values. Here is the function. We used a function and it returns some values of type unsigned integer. So we will compile it and we will take care, we will use the same compiler version we like declared here. So we will use 0.5.0. Here we compile it. So our smart contract is successfully compiled. After successful compilation, we got two things. One is ABI and the other thing is bytecode. When we want to interact with the deployed smart contract, the two main things that are used in the front end are API and bytecode. So now we deploy our smart contract. After compilation, the next step is deployment. The first step is writing down the smart contract. After the completion of writing, the second step is compilation. We go to compile module and we compile it using the same compiler version we defined in the here using the pragma. After successful compilation, the compilation can be successful or unsuccessful. If it is unsuccessful, it will give some error in the output section. So you can go through those errors and like solve those errors fix those errors and then compile again. Once it is successful, after successful compilation, it will give you ABI and bytecode. It wouldn't give you ABI and bytecode like before the successful compilation. So here is the deployment. Before deployment, you need to have a MetaMask and have some coins, test coins, if you want to deploy on the testnet, and main coin if you want to deploy on the mainnet. So I have some coins already. If you don't have coin, you can go to uh, test network coin provider website and paste your this address, MetaMask wallet address, and you will get some test coin very easily for the testing purpose. So now we will deploy our smart contract. As I talked earlier, for deployment we need some gas fee. Whenever we deploy our smart contract and whenever we make some interaction, like when we store some data on the blockchain, we need some gas fee. But when we retrieve some data from the blockchain, we don't need any gas fee because we are not making any transaction on the blockchain, or like we are not storing any data on the blockchain. When we store any data on the blockchain, like when we deploy a smart contract, that is also one case like we are storing some data on the blockchain because sorry, this wrong smart contract is compiled. We will deploy this smart contract. Yeah, for example, when we are deploying our smart contract is being deployed on the blockchain, so some resources are being used. You are not paying, like those resources does not belong to you. Those are the nodes, those are the Bitcoin miner, or those are the Conflux nodes. Like we need to pay to them for storing our data. And when we make some transaction, for example, when we store some data in our smart contract, we need to pay some gas fee, like according to the data we have in our smart contract. For example, if we have more data in our smart contract, we have used like unsigned int 256, for example, we need to pay extra gas fee. And if we have used unsigned int 16, so it is using less memory, we need to pay less gas fee. So we need to consider about this also. When we write down smart contract, we need to be very efficient in this scenario because we are using blockchain. If we talk about like other use cases in databases, is not very important maybe, but in the blockchain case, this is very important because your gas fee is directly proportional to the data you have in your smart contract. If you have large data, you need to pay extra gas fee, and if you have less data, you need to pay low gas fee. So here our smart contract is compiled successfully on the Conflux blockchain, on the Conflux eSpace test network. So here is the contract address. We can verify also on the Conflux eSpace test network. So here we have one function in this smart contract, and we use that function to just retrieve the value, not store the value. We didn't like pass any argument in the function, but we returned some arguments in the function. So here we use constructor to define the value. So here we get value 10. So here we got one example of a smart contract of an instructor, like how we can write down a smart contract, how we compile a smart contract from basic, from like very beginning to deployment. We can check it on the Conflux eSpace test network also. As I talked earlier, blockchain has yeah, Conflux eSpace Test Network Scan. Yeah, Conflux Scanner. So here we can check all the transaction we made. So I mentioned earlier why we need blockchain, why we don't use databases. If we compare blockchain with databases, I would like to highlight the biggest comparison. In databases, we can update our transactions. For example, when we make any transaction, a transaction is stored in the database, but that transaction is updatable. Database has a query update. We can use update query to update any transaction in the database. And like, but that is not the case with the blockchain. Once a transaction is recorded in the blockchain, we can never ever change or update that transaction. This is one of the biggest advantage of the blockchain. So this is like one of the features of the blockchains among many usable features. So we have deployed our smart contract on the Conflux eSpace test network. So here we will check Conflux eSpace test network. What is a blockchain here now? A blockchain is a set of nodes holding your smart contracts all around the world. Once you deploy your smart contract, you cannot make any changes. Anyone else cannot make any changes in your smart contract or any transaction made in the smart contract. So we deployed our smart contract. And the second thing is you can verify your transaction all around the world. You can check your smart contract deployed on the blockchain from all around the world. So we deployed a smart contract. We can check using the smart contract. Uh, Sorry, where is the smart contract? Here we can check the using the smart contract ID. Okay, yeah. So if we paste here, we can see we have deployed a smart contract. Is transaction hash is this one, and block hash is this one timestamp. Like when your smart contract is deployed on the blockchain is 6 minutes ago. So this is my MetaMask wallet address from. Yeah, if we go here, uh, I'm using this one. Yeah, if we go here, we can check like from. From is like the one who is interacting with the smart contract. Message dot sender is also the same. Like here we can see from is this one and to the smart contract. This is the contract address where the smart contract is deployed. This is my wallet address. And this is the gas fee that is used to deploy a smart contract here. Is very low gas fee. So here I would like to discuss about gas fee also. Like some blockchains take very few gas fee. There are many blockchains. So some are like some are EVM supported, some are not EVM supported. Some supports like proof of stake algorithm and some more supports proof proof of work algorithm. Proof of work algorithms you need to like that is like for the not for the developer understanding but for the miner. Like they had to calculate the hash code to get like the you can say the price for the mining. Like all this data is stored in a block. So someone is mining that block. So there are two ways to mine a block. One is proof of work, the other one is proof of stake. Proof of work, for example, if you want to mine a block, you need to calculate a hash code. Once you calculate the hash code, you can add that block in the blockchain. So that is known as blockchain, the chain of blocks. So you will be rewarded some local token. For example, if you are a miner on the Conflux network, you will get some CFX. If you are a miner on the Ethereum blockchain, you will get some ETH. If you are a miner of Bitcoin, you will get some BTC coins. So this is proof of stake and proof of work. The other one is proof of stake. For proof of stake, you need to like have many coins in your wallet, so then you can be like successfully mine any block. So that these things are like to be considered on the miner side, not the developer side, not much on the developer side. So here we see how we can deploy a very simple smart contract on the Conflux blockchain. So here I have to pay some gas fee. I already told this one is the gas used. So this was a very simple smart contract. Here I will write down another smart contract, a very simple smart contract to store some data. So these smart contracts are written in Solidity programming language. And once it is deployed, our smart contract is deployed on the blockchain. Like even without this compiler, we can access that smart contract anywhere in the blockchain. So here I said is like chain ID supports intelligence. You just like use some keyword and it will automatically give you some hints. Pragma, Solidity. Here we will use some compiler version. Yeah, for example 0.8.0. So here we define the compiler version. Next is the contract. Here our contract starts. As I already talked, a contract is like a class. It has some data types, some values, and some functions. And something to be very careful when you name a contract, you shouldn't use system specific reserved words. For example, you cannot use solidity here as a name, or you cannot use like some other reserved words. Reserved word, for example, block. You cannot use block as a contract name because it is a reserved keyword. It will give some error. So you should use some other more words related to your smart contract. For example, here we want to store and retrieve some values from the smart contract. So we will use store, uh, yes, just to store, or we can use store and retrieve like this. So here our smart contract starts. So it has some values. We define int. We will define some values we want to store. For example, we want to store here int id, and we want to store int uh, mobile number. Sorry, yeah, mobile number. So mobile number is also an integer. Oh, sorry, here it will be. So next, I want to store string name, and I want to store string address. We see here address is a reserved keyword, so we shouldn't use address. So we can use this instead of just address. So we will use two function, one function to store the values and one function to retrieve the values. So here we use function store data. So this function is used to store the data and we retrieve this public as a public. Here we want to pass some values to this function. For example, we want to store ID of a user, some mobile number of a user, name of a user, and address of a user. So we will pass this value to this function. First one is ID. The second one is mobile number. So we are passing some arguments to the function. A function will ask for these requirements as an input. So here we string name and string address. So here it will ask for the values. So we are not returning any value, so we wouldn't use any return keyword. So here we will like assign these values to the state variables. These are state variables. These all are state variables. So we will assign these values to state variables ID. The values we are taking using this function ID, mobile number, sorry, this one, and name and address. So here we can use double A. So this function will take these values and now we want to return these values also. So we will use another function to retrieve these values. So function uh, retrieve we can say. That might be very easy for the developers who have understanding of the programming language. But our main purpose in this video is to make able to very beginners who don't have basic understanding of solidity of or smart contracts to have them understanding and be able to uh, make them like they can write their own smart contracts by themselves. So functional retrieve. So here we are not uh, taking any parameters but returning something. So here we will use public view returns. So here we will return some values. Here we will return ID, mobile number, name, and address. So the first function is used to retrieve, store the value, and the second function is used to retrieve the values. So here we use unsigned int, and here with string we should use memory keyword. Unsigned int integer ID and mobile number. This is very easy and this is just for the beginners. Memory name and string memory address. So this function is used to retrieve the values. So now we will see if there is any error in this program or not. If there is no error, so it will be compiled successfully. But if there is any error, it will be shown in the compiler. So we have written down it completely, so we will compile it. We will use the same compiler version 0.8.0. Uh, Unsigned integer store value. Oh, sorry, int id context to retrieve int id. Yeah. So there are some errors. There are no compiler version in 0.7.0. So we will see here. Uh, oh, contract store. So here we try contract store int id. So here is some problem with it. Unsigned, unsigned integer because we want to take both negative and positive values. So uh, here is some value a problem with it contract store. Just let me have a look. Solidity contract storage. Yeah, I think the store keyword is also the reserved keyword. So I will use contract storage. This one. What is the problem now? Unsigned int number. Just let me check again. ID. Yeah, ID is not the reserved keyword. Uh, Unsigned int ID. So we will see if we have any error here. So here we have, there are no compiler version in 0 point. Oh, I think here I didn't use this uh, comma, colon. So be very careful when you write down, and when you have some error, you can check in the compiler version. So here I had not used this colon, so that's why it was giving some error. So after I used it, is working normally now. So there might be some problem because here I declared unsigned integer, but here I am using int. So we can also use unsigned integer because it is required. Yeah, so this is the error. So I will compile again. And we will check if there are some other errors. So here we have another error, string memory address public. Expected this but got this one. Here we can see here is the error. I shouldn't have used this symbol, string name. Should use single comma. Yeah, so we will check if there is any other problem. Here is another problem, parse error but got this one. So whenever you have some error, you can check in the output section. So this is very normal. So I write down this code and on purpose, for example, if I have some errors, so you can get to know like how you can fix these errors. So I will compile again. Yeah, so now the smart contract is compiled successfully. The function that stores value is compiled successfully, but there is a problem with the function that retrieves some values. So we will check this function also. What is the problem? So when we retrieve the values, yeah, so let me check. I have written down before unsigned int. Yeah, so I get the problem here. So we don't need to define these, just unsigned integers. Yeah, so we'll try to compile now and we check if there is any other problem. Yeah, there is still an other problem with this. I will see unsigned int string memory. Here I have written down function retrieve public view returns unsigned integer string memory. Yeah, return ID, mobile number, name. Yeah, here because we are returning more than one values, so I will try to return just one value, return ID and compile. So there is a problem like here. Uh, let me check here. Here I am returning more than one values employee info.cs. Yeah, so this is the way string memory, mobile number, ID, first name. So unsigned integer. The first one is unsigned integer. The second one is also unsigned integer. The third one is string, and we will use string memory keyword with string. Here is also string. So ID and mobile name. Here is name and here is address. So yeah, I think it should work normally now. Yeah, so our smart contract is successfully compiled now. And as I talked earlier, after a successful compilation, it will generate API code and bytecode. It have already given us bytecode and API code. So the next step is deployment. So before deploying, please be careful like which smart contract you want to deploy. In the deploy section, you can see different smart contract you have compiled, but you need to like choose the one you want to deploy. So we have compile store data. So we can check here store data smart contract. Store data. Yeah, here we can see here is the store data. So we will choose this one to deploy our smart contract. So for deploying, we will need some gas fee. After successful deployment, we can interact with the smart contract. So these are very, very basic and simple smart contracts just for the understanding. Here is the deployment and interaction panel of Chain IDE. Here you can retrieve value and store value. For example, here we make interaction with store value, and here I want to store mobile number. Here I want to store the name is string, and here I want to store address Nanjing, China. So here I will submit it, and when we submit it, as I discussed earlier, we need to pay the gas fee because we are using blockchain resources. Like someone, the nodes have paid for the machines, like where our data is being stored. so we need to pay for the resources. But when we retrieve the value, we don't need to pay the gas fee. So here the value is not updated yet. So we will click here. Here we can see the data is updated now. The first, like here is one thing to note. When we store the data on the blockchain, we need to pay the gas fee. But when we retrieve the data from the blockchain, we don't need to pay the gas fee. So this is another smart contract, very simple smart contract we deployed on the blockchain. So this smart contract and the transactions can also be verified from the blockchain. Here we can verify all the transactions and the smart contract. Here is my address from, here is the contract address, and here is the transaction. Here is the block height, block hash. So these are the very simple smart contract, very basic smart contracts I have like written for you, especially for the beginners who don't have any understanding of the blockchain. So these two smart contracts I designed. The third one is inheritance. In inheritance, we have different smart contracts. One is parent class, one is child class. So here is the contract C, which is known as parent class. Here is a private uh, data type. We cannot use it in the derived data type, but we can use public data type in the child or derived data type. So here in the parent class, we have defined two state variables, and here we have used constructor to define the value. Here we declare the variable, and here we define the value for the variable, and here we define the function increment, like it increments one in the value of like the value which inputs. Here we have three different functions also, and here we have derived smart contract. In inheritance, we inherit some of the state variable from the parent class to the child class. Here is the derived class, and we will inherit public data types we declared in the parent class in the derived class. So here we can see we used info. We declared in the parent class, but we are using it in the child class. So this is what we call inherit. We inherit some of the key features, some of the data types from the node class to the child class. So this is another smart contract to understand the inheritance, to understand the data types, to understand the modifier for the data types such as private, public, and to understand the constructor. Here we have used constructor. We defined a value to a constructor. A constructor is only called once when a smart contract is deployed on the blockchain. After that, we can never use a constructor. And another thing to notice that in a smart contract there can be only one constructor, cannot be more than one constructor. Here we an function is taking some parameters and returning some parameters. Here we will give some value, and it will increment one into that value and return us. So the main purpose to show this function, this smart contract, is to understand the inheritance. Like here we have used in c.info is declared in the parent class, but we are using it in the child class. So we will compile this smart contract now. Yeah, so this smart contract is also compiled successfully. We can see the ABI files and JSON code, bytecode of this Here is API file and bytecode. We have two smart contract in this uh, contract. The one is C, the other one is E. So here we can see both of these smart contract. And here we would like to deploy smart contract E. Yeah, after a successful deployment, we can uh, interact with the deployed smart contract in the interact panel. We deployed E successfully and we see get data. Get data, we see what it gives us the value. It gives us 10. We didn't use 10 in the derived contract, but we used 10 info here in the private in the parent class, but we used it in the child class inherited class. So this is inherit. We inherited the value from the parent class to the child class. We see info. We did not declare info in the child class, but we declared info and it's defined its value in the parent class, and we used it in the derived class. So this is inheritance. I hope all the audience have clear understanding what is inheritance, what is a smart contract, what are data types, what are the data type modifiers like private, public, and what are the function modifiers, public functions, private functions, what are the pure functions, what are the few functions, what are the use cases of it, what is constructor, how to use chain IDE, how to use MetaMask. I hope all the audience will have very clear understanding and will be able to create their own smart contract using Chain IDE and deploy it on the Conflux blockchain very easily. Here we will go to CRC20 smart contract now, which is a fungible token. We can transfer token from one wallet address to another wallet address. We can make some utility of this smart contract of this fungible token, such as Solana is a fungible token. They have the utility. For example, when you need to deploy a smart contract on the Solana blockchain, you need to have SOL token. When you need to some like bridges, you need to have SOL. There are many use cases of SOL tokens, and the same is the case. You can also make some utility of your smart contract and you can also sell your fungible token. So we will move forward to CRC20 standard token, which is a fungible token. Yeah, so here is the CRC20 standard token. Here is the file of CRC20, and safemath.sol is also for CRC20 standard token. So here is a code for the CRC20. Here is the name for the token. Here is the symbol for the token. Here is the decimals, like which how many decimals you want. For during this I talked like there are stages of the software development. We can see like there are stages of token development also, like you need to plan first, you need to compare with your competitor, like if there is any competitor. For example, a token for Ethereum blockchain, you can have understanding, you can have ideas from their tokens, like how many decimals they used, like how much is their supply, what is their utility, how you can use your token. So that was the main purpose for like telling the life cycle of a software. So here we have function total supply, here we have mapping function, transfer function, we have events, here we have constructor. As I already told you, the constructor is very important. And this smart contract is available in Chain IDE built-in templates. You can go to Chain IDE anytime and can use this built-in template, can make any changes, and can make your own fungible token. Here are all the functions, like for example, if you don't have enough balance, so you cannot transfer, your balance should be less than the value you want to transfer. And this function takes two values, like a transfer from like the address where the sender address, the receiver address, and the value the sender want to send to the receiver. So this is the CRC20 standard token. So this is also very simple standard, very simple smart contract. You can understand it. You can go to chain ID after this uh, lecture. You can understand it. If you have any confusion, you can ask in the Telegram group. We will compile this. Yeah. So this one is also successful. So we will deploy it. So this one is CRC20. So we will deploy it. After the successful deployment, you will be able to see all the functions in your smart contract in the interact panel, and you will be able to interact with your deployed smart contract. So our smart contract is not successfully deployed yet. So, so our smart contract is successfully deployed yet now, and we can interact with all the functions in the smart contract. So here we have allowance function, and we have different other functions also. For example, name of your token, the CRE test token is the name of our token. What is the standard of the token? The token is zero point 0.1 token. If you improve it, you can name it zero point 0.2. The symbol of the token is CTC. What is the total supply of the token? You can check here. Here, this is the number of total supply. Here is a transfer, like to whom you want to transfer. For example, here I want to transfer to another wallet. I will go to another wallet, and I will copy my this address to receive some tokens. For example, here I want to and these many tokens. So this transaction is sent from like my address to my other wallet. So this is how you can transfer your tokens from one address to another address. These are all the functions of the CRC20, and you can add this token to your MetaMask wallet also. For example, here I already added CTC. So now I have this number of tokens in my wallet. So you can go to assets, and if you want to import here, you can import using token contract address, the address of a smart contract you deployed. Here you can check. Yeah, the token contract address is this one. You can copy from here. Copied will be copy here. So you can go to your MetaMask wallet and add your token here. Here will be yeah, because I have already added this token, so they say this already token has already been added. So here you can see this is the token, and I can send this token to any other address also. For example, here I want to send to another wallet. Here I have received already like CTC I sent from my other wallet to this wallet. For example, I want to send more. I will copy here and I can send very easily this token, this to my other wallet address. Here I will see like how many token I want to send. Here I chose this amount. So this was the very simple and clear method how you can create your own fungible tokens and can make transaction your deployed smart contract, how you can add this token to your MetaMask wallet, how you can transfer from one wallet to another wallet. So this was very clear. Here I will see if I have received. Yeah, here you can see I sent 299 CFS token from one wallet to another wallet. So these both are my wallets. I transferred from one wallet to another wallet. So this was the CRC20 token, non-fungible token standard, and you can access this from the chain ID built-in templates also. You can add conflux e-space into your MetaMask. I have told each and everything. So for the final demo, I have prepared an other smart contract and created front end using HTML and CSS, deployed a smart contract on the blockchain, and I interacted using the front end. So here is the our last demo. Let me find. Yeah, this one. So this is our last demo for this lecture. So here we have three things. The first one is our smart contract. The second one is our front end. Yeah, the third one is readme.md just to make the users understand. Here I have created this smart contract to store the information on the blockchain and retrieve the stored information from the blockchain using front end created using HTML, CSS, and JavaScript. Here is the code. First of all, I used HTML tags, HTML head, and title and link. I used two links. This one is for the CSS and this one is for the JavaScript library. It is very important for all the audience to understand JavaScript J3 library for Conflux blockchain and for Ethereum blockchain. You can easily go to the here Conflux developer and you can find here the all each and everything about the Conflux blockchain and you can JavaScript J3 library. Is Web3 is also known as Web3 library is used to interact with the deployed smart contract on the blockchain. Web3 library is very important. So you need to have like good experience in Web3. So this is the heading I h1 like heading one, and these are all the HTML tags I have used. The input tags for different inputs for the ID, name, password, mobile number, and address. And here I have used some to show the display. Like the I have used some IDs, uh, yeah, labels to display the information on the front end. Uh, yeah, and here I have used Web3 library and JavaScript. Here is the smart contract. I already written down this smart contract in front of you to store the information on the blockchain and retrieve the information on the blockchain. So I deployed the smart contract already on the blockchain. So, and I used the deployed smart contracts API. I already told you the API and the bytecode is very important when we want to interact with the deployed smart contract using the front end. So, and the contract address. Here is the contract address. Here is the API I have already deployed on the blockchain to save time because we don't have enough time now. So I already deployed it. Though, so this is the function to store information using J3 library and JavaScript and like HTML tags. From the HTML tags, I take the input values and use the function and pass the values to the like the deployed function using J3 library and JavaScript. This is my wallet address. I will be using this wallet address to store the information on the blockchain, and this is the to retrieve the information to load the information from the blockchain to the HTML labels. So I will compile this in front of you to have better understanding like how this works. And I deployed it on the another blockchain, so I will change it. So this is the output of this demo. This smart contract has already been deployed on the blockchain. This is the front end created using HTML, CSS. Here is the CSS. I already told CSS is used to design, add the colors to design. HTML is used to make the like a whole content, like the buttons, the input fields, the text that is used to display on the front end. But CSS is just used to like change the font color, design to add this text color and this other colors, yeah, and to make different forms, CSS is used. Three things are used: HTML, CSS, JavaScript for the front end. Web3 JS is also JavaScript is used to interact front end with the back end. The smart contract we deployed on the blockchain. So here we will interact with the deployed smart contract using the front end. So this is the front end. Here is the ID like one. Here is my name Ali. Here is Arshad. Arshad, sorry. And here is the address Nanjing. And here is the mobile number. So here we will save this value. For saving, I already told we need to pay the gas fee every time whenever we make a transaction on the blockchain. So after saving, we will retrieve this information from the blockchain. So here we will click show. So here we can see the value stored on the blockchain can be seen using the HTML page. So if you want to practice to this demo I have uploaded all the code on my GitHub repository. And you can go to my GitHub repository and you can check this repository ERMS employees uh, RMS blockchain, and you can check HTML, all the smart contract, CSS, and Web3 library. All the code is available. You can make changes to it and can practice for the better understanding. That was all for today's video, and I hope it was clear, informative. And now I would like to have any questions. We don't have much time. I would like to have questions from your side.
All right, thank you for the elaborations, Ali. Today we have been went through a bunch of steps related to technical side.
Okay.
Again, if you have questions, please feel free to ask and about anything you want about conflicts, about Chain IDE in our Telegram group, or for any help. And we will soon send a Google form in the Telegram group as well. And don't forget to spend like just 1 minute, fill out the form for the special poll. We made it for you. Also, a kindly reminder for the next week is about how to develop a blockchain-based game. Make sure you mark it down and then you make sure you don't miss it. Um,
Yeah, here I would like to answer some questions from the audience. If we have
okay, go
yeah,
ahead.
we have some time. We have one question like how easy is it for a beginner to make use of Chain ID? I would say it is super easy. You don't need to install any plugins. You just need to go to Chain IDE. Chain ID have built-in templates for all the audience. They can make changes according to their requirements, can learn from the built-in templates. And like it's very easy. You saw, just need to write down the code, you need to compile, and you need to deploy. You don't need to install any, like even any a single software except chain IDE. It has each and everything built in it, so it is super easy and super user friendly, I would say. And here it's really to get started with templates. You can load one and modify it easily. Yeah, so these were all the questions for today. And one have a question like, how can I contact with Mr. Ali? What are his social contacts, like GitHub or LinkedIn profile? I have already shared my GitHub profile, and I will share my Twitter profile also. If you want to, if you have any questions, you can reach me at Ali Arshad M. Here is my linked Twitter profile, and I have a LinkedIn profile also, but I think I have already shared my GitHub, my Twitter profile, and you can email me at ali at the rate of whitematrix.io. Yeah. Can this be used offline? So the chain IDE cannot be used offline. This is online IDE. You cannot use it offline. You need to have access to the internet to use chain IDE. So that was all for today's session. I think we don't have any question for now. Thanks a lot for being with us today again. I hope you really like learned a lot, like really lot. Like I would like to say, the beginners learned a lot. Maybe it is nothing for the ones who are advanced in coding, but I think it is good for the beginners. So that is all for today. And as um, our colleague already discussed with you, don't forget to fill in the link given in the description. And our teaming is still in uh, progress. We have uploaded links in our Telegram group for the team making. We have $7,000 as the prize to the best projects, like the ones who will build best projects. We will like give them $7,000. So to win $7,000, you need to make some good projects. First of all, you need to go to IDE, our Telegram channel. There we have uploaded links for the team making. You need to upload the information for all the team members and your project. So before do that before 15th of April. Thank you so much. Yeah, you can use React with Chain IDE. Yeah, thank you so much for being with us. If you still have any questions, you can ask in our Telegram channel. I have posted my contact links in the. I have showed you my contacts links. You can reach me anytime. My email address is contact at the rate of sorry, Ali at the rate of whitematrix.io. Thank you so much. Have a nice day. So we will end this meeting now.
Okay, thank you again, Ali, and also thank you for everyone today being with us. We will see you guys next week, and you guys have a wonderful night. Bye bye.